Hello everyone, I am Pavithra. Next, we can see about digital signatures in blockchain. So, digital signature algorithm is used to ensure the authenticity of a digital message at generating a unique hashtag of the message or document and encrypting it is using to the sender by the receiver of the private key. So the elliptic curve digital signature algorithms is called by ECDSA. An elliptic curve is a curve defined. It is the particularly useful because it uses the relatively short key lengths compared to the other digital signatures algorithms. So the first of all, single signing the messages with the private key and verifying the messages with the public key. So the data has been messaged to the hash function. So the encrypt using the signer privacy. So the digital signature be attached to the data. Finally, the digitally signed the data could be ready. So the digitally signed data to a column by decrypt using signer public key. So the should match for the data and the private key. So the next one, digital signatures for the key generation. The key generation process ECDSA involves choosing a specific elliptic curve and a point on a curve known as generator point. So these two elements are publicly known as or are used to generate private or public key pair. The generator pointer is a selected point on a elliptic curve that can generate every point on the curve through scalar multiplication. So the scalar multiplication is a process of adding a point on the curve to itself a certain number of times. So the private public key is randomly generated a number and the prior public key is that obtained by performing scalar multiplications on the generator point. So the next one, signature generation. In ECDSA, the private key is used to create signature by generating a random number and performing series of mathematical operations, including modular arithmetic and elliptic curve. So the point of multiplications on the nonce and the hash of the message. So, public key recovery, the next one. The public key recovery is a technique that allows a recipient to obtain the public key of a sender from a digital signature. This is commonly useful in the blockchains where you want to verify that signatures from a certain public key. So the digital signatures is in this cryptography. The key is shared between two users. The first one, the sharing of key is a problem. However, this technique is faster than public key cryptography. So the examples of advanced encryptions in standard AES and the data encryption standard is DES. So, symmetric key cryptography it is also known as a public key cryptography. Since there is a problem with sharing the keys, symmetric encryptions, this method is used here. Only the key is public and another key is private. So, the public key is used to encrypt or lock data. The private key is used to accessible for the receiver. So these are the digital signature processes on the key generations. The first one of all, signature generation and the public key recovery and symmetric key cryptography and asymmetric key cryptography. So the advanced encryption standard method used in data encryptions. So the since the data is a problem, it should be run for or shared different users. The sharing of the key problem is the technique to public cryptography is used for the symmetric key cryptography. So the symmetric key is two ways of the cryptography for first of all and public key and private key. So the public key encryptor is the one of the method for lock data and the private key is one of the for accessible to the receiver. Thank you.